Okay, I'm going to take a look at problem 14-8. This is a, a pulley problem. I wanted to look at least one pulley problem. So in this particular problem, you have a force pulling down on uh, on the right hand side, and that's causing this weight to lift. Okay. What we'll notice about this problem, you have this couple of lengths of rope, but the one we care about is the length that goes down through here, wraps around the pulley, and comes back around. Okay. And what we're going to do is we want to figure out, in this case, this is a 10 kilogram block, and it moves up a certain distance, and we care about it at 1.5 meters from starting from this point right here, starting from rest. Okay. Well, one of the things we're going to recognize if we look at this right off the bat is that there's a relationship between how far this moves and how far essentially this pulley wheel goes down. Or if you want to think about it as how far this weight is actually, I'm not sorry, not the weight, the force, how far um, this wheel goes down. So whatever force is applied, whatever distance this is traveled downward. Okay. So we'll start with this. Here's 14.8. And basically, we're going to start off with thinking about, oh, okay, what's that, like that velocity, the final velocity, V2, okay, of the block. So in this case, we're just defining it saying, okay, it's moved 1.5 meters, right? So what's given? Force 250 newtons, the mass of the block, and then like our initial velocity, right? In the problem statement, it says it's starting from rest. So we just define that as being zero. So we have no initial velocity. Now the same thing we can look at is displacement, right? And we have to think about it in terms of, yeah, it's going to move certain distance. So what we'll define is saying that where it was initially, just set that equal to zero. And then through the displacement, the total displacement of 1.5 meters. And we'll just define this as the delta. So the difference between these two being the delta 1.5 meters. Okay. The next thing we'll look at is, so, start off, find what's given, the governing equations. And part of this, this is our work energy equation. Um, Part of this, we need to come up with a relationship between the displacements, right? And what we're going to notice here, essentially, this is kind of a crude free body diagram, but best I could do by freehand. Um, so here's my free body diagram, and I have some relationships. And here, what we'll say is we'll define something. This is the, you know, distance of the weight. However, we can divide this from position, basically from whatever. This is our initial point or our datum point, and we'll represent that as just SW. The next one is we'll have displacement from that same point down is our SF, or force distance of this pulley due to our force. Okay. Well, if you look at it, you think about, well, there's a length of rope here that's wrapped around this upper pulley, and it's moving, essentially for this to move, 1 meter, this moves only half a meter down, right? Because it's the same length of rope. It'd be half over here and half on this side, okay? So there's a relationship between the delta SF, that force pulling down, and the delta of the weight. And really what you're going to find is that um, it's twice, right? It's twice the distance, or this delta SF moves half as much as this side. Okay, so here's the relation. 2 times delta SF is equal to the delta SW. Okay, so twice this length down, or displacement down. All right, so what we could do at this point, we could just go ahead and substitute in for that displacement of 1.5. And when we do that for SW, because it's the displacement of the weight or the block, and we come up with a delta SF, okay? And that's just equal to 0.75 meters. Okay, for our approach in terms of solving this problem, we're going to have work of force and we're going to have work of the weight. Okay, so first thing thinking about it, okay, so force times distance, that gives us a work. There's the work of the force. And the second part is the weight, right? So we have a force, the weight is the force, And notice the difference, the distance is, I'm sorry, the signs related to these two. And we could just write it as, I wrote it as a negative 10 kilograms times 9.81. Here's our force, here's our W times the distance. And that comes up to be negative 147 joules. Okay. And the idea was, of course, we're going in the opposite direction. The weight's being pulled up. So our work is going to be negative in this case, right? So we've come up with these two work, one due to the force and one due to the uh, weight. Okay. Now the third step will apply the principle of work and energy. All right. So we have our initial energy or kinetic energy associated with the block, which is zero because it says it starts at rest. And then work is being done. Okay. Positive work of the force and the negative work of the weight. And that is going to be equal to the kinetic, here's the final kinetic energy of the block. All right. So all we have to do is substitute in for the kinetic energy of the block, the final kinetic energy, the initial kinetic energy, the work due to the force, and subtract out the work of the weight. And when we solve for that, we come up with a velocity of 2.84 meters per second. And that's pretty much it for this problem.